Okay. Good morning, students. Good morning. So my name is SHYAM PATIL and I am physics lecturer in Sri Guru College from many years. Okay. So I will be taking a first year topic physics. So that is fluid mechanics. Fluid mechanics, or you can tell mechanical properties of fluids. This is second part. It is there in the second part of the syllabus. So that is second half of the syllabus. So mechanical properties of solids. After that, we'll study mechanical properties of fluids or fluid mechanics. Okay. So looks like very small chapter. Syllabusally it is a small chapter, but when you go deep into the physics, it is very big. Okay, so whatever. So we'll start with this one. This is lecture number 1. Lecture number 1. Okay, so few lecturers will complete this chapter. Okay, fluid mechanics. So first let us begin with physics only. So what is physics? This is first year class, so that's why I will start with physics only, first year syllabus. So what is physics? What is physics? So many of you know already, we have studied in the first part of the syllabus. So that is physics is study of nature and natural phenomena. That is, in general you will tell that physics is the branch of science which deals with the study of nature and natural phenomena. There is another definition. What is physics? Physics is physics is a study of matter and energy. Just you can tell physics is the branch of science in which we deal or we study about the matter and energy. So now, what is matter? What is matter? Anything which occupies space and having mass is called as matter. What is matter? Anything which occupies the space and having the mass. Anything which occupies the space and having the mass is called as matter. What is energy? Ability to do the work is called energy. So the study of matter and energy is called as physics. This is another definition. Okay, no problem. So we know that matter. So let us come to the point. Matter exists in different forms. Matter exists in different forms. Mainly, basically, we will study only 3 forms. That is solid matter, liquid matter and gaseous matter. Matter exists in 3 states: solid state, liquid state and gaseous state, right? Okay. So now the liquids and gases can flow freely. The liquids and gases can flow freely and does not have a fixed shape of their own. The liquids and gases can flow freely, can flow very easily and does not have a fixed shape and fixed shape of their own. Hence, these liquids and gases collectively called as fluids. These liquids and gases collectively together called as fluids. So fluids are those substances. Fluids are those substances which can flow under the action of an external force. The fluids are those substances which can flow under the action of an external force and does not have a particular or fixed shape of their own. Such kind of substances are called as fluids. The substances which can flow under the action of external force and which does not have a fixed shape of their own, such kind of substances are called as fluids. Okay. So now, in this chapter, this is fluid mechanics. Okay. So fluids, what are fluids? You understood? The substances which can flow under the action of an external force. Or just a small force is applied, then also the fluid, that is liquids and gases, can very easily flow. If you leave the liquid, so they will start to flow, that is due to the gravitational force. They will start to flow due to the gravitational force. So gases are also okay. So that liquids and gases collectively called as fluids, and they will not have their particular shape or particular fixed shape or size. Okay. So now the study of fluids at rest, the study of fluids at rest is called fluid statics. The study of fluid at rest is called fluid statics or hydrostatics, or we call it as hydrostatics. That is the branch of physics which deals with the study of fluids. The branch of physics which deals with the study of fluids which are at rest is called as fluid statics or hydrostatics. And the branch of physics which deals with the study of fluids, the branch of physics which deals with the study of fluids which are in motion, the study of fluids in motion is called as fluid dynamics, is called as fluid dynamics or hydrodynamics. Okay. The branch of physics which deals with the study of fluids which are in motion, the branch of physics which deals with the study of fluids which is in motion is called as fluid dynamics, or fluid dynamics is also called as hydrodynamics. And the branch of physics which deals with the study of fluids which are at rest is called fluid statics and fluid or hydrostatics. And both fluid statics and fluid dynamics both will be studied in this fluid mechanics. First we study fluid statics or hydrostatics, and after that we will study fluid dynamics and hydrodynamics. Understood the introduction? This is all introduction. It's all the things about introduction to this chapter. I am teaching the chapter called fluid mechanics, and these all are the things are introduction, just for your understanding. Okay. Hope you understood all these things. Huh? Okay. So now we study fluid statics or hydrostatics first, and after that, after it will take 2 or 3 periods. Fluid statics or hydrostatics will take 2 or 3 periods, maybe 4 periods also. So after that we will study fluid dynamics or hydrodynamics. Okay. So in this hydrostatics or fluid statics, we will be studying about the fluid which is at rest. So now the main important point or the main point that comes to our mind is pressure, fluid pressure. So we have to understand pressure. Okay. So now we will study a little bit differently. So carefully understand. Okay. So there is a container. In this container there is a fluid. Fluid means liquid or gas. You may take liquid. Okay, better. It will be liquid. So a liquid is there inside a container. And now this liquid, the liquid which is present at rest in a container, this liquid continuously exerts a force on the walls of the container. Remember that a liquid in contact with a surface, a liquid inside the container, a liquid at rest inside the container will exert a force on the walls of the container. This liquid will exert a force on the walls of the container continuously, like this. So it will exert a force on the walls of the container. Understood? So this force we called as, and this force will be perpendicular or normal to the surface. This force will be perpendicular or normal to the surface, and this force we can call it as thrust. We will call this force as thrust. And due to this force only, when a hole is made to this container, if a hole is made to this container, the fluid will come out. If a hole is made to this container, the liquid will come out due to the thrust only. This thrust is exerted by the liquid which is present inside the container. The liquid at rest which is present inside the container will exert a force on the surface of the container, and this force exerted is perpendicular to the surface of the container. This force exerted is perpendicular to this area, and this force we call it as thrust. Understood? That is the normal force exerted by the liquid at rest. Thrust, I am giving a definition for thrust, just a definition for thrust. A normal force exerted, the normal force exerted by the liquid at rest. The normal force exerted by the liquid at rest on a surface in contact with it. The normal means perpendicular. Normal, meaning of normal means perpendicular. Perpendicular means you understood. Hope you understood that much. The normal force exerted by the liquid. The normal force exerted by the liquid at rest. The normal force exerted by the liquid at rest on a surface in contact with it. On a surface in contact with it is called as thrust. The normal force exerted by the liquid at rest on a given surface in contact with it is called as thrust. For example, if there is a surface is there. Okay, now in this liquid we have a object is there. This is liquid is at rest. So now a object is immersed. A object is kept inside this liquid like this. So when an object is kept inside this liquid, this object, on the surface of this object also, the liquid will exert a force. On the surface which is in contact with the liquid, on the surface which is in contact with the liquid, the fluid will exert a force. Understood? And that normal force means the perpendicular force exerted by the liquid at rest on a surface in contact with it is called as thrust. The normal force exerted by the liquid on a surface in contact with it is called as thrust. Understood? So now next point, next one is pressure. So now understand pressure. What is pressure? The normal force exerted by the liquid, at rest, the normal force exerted by the liquid at rest per unit area of the surface in contact with it. The normal force exerted by the liquid at rest per unit area of the surface, in contact with it is called fluid pressure. The normal force exerted by the liquid at rest, per unit area of surface in contact with it, is called as pressure. Or you can just simply say that the thrust acting per unit area, of the surface is called as pressure. The thrust applied per unit area of the surface is called as pressure. That is, if F be the normal force exerted by the liquid at rest, if F be the normal force exerted by the liquid at rest on a surface area A in contact with it, then pressure is given by, that is P is given by F divided by A. P is equal to F divided by A simply. Or you can just simply tell it as pressure is equal to force divided by area. That is, you have studied in the mechanics also. The first part of the syllabus also you will study like this only. Pressure is equal to force divided by area. It is fluid pressure. Kaunsa pressure? Fluid pressure. So fluid force. Kaunsa force? Fluid force divided by area in contact with the fluid. Understood? Not just ordinary pressure, it is fluid pressure. So we will take fluid force and area which is in contact with the fluid. Understood? So it is P is equal to F divided by A. And the SI unit of force is Newton and the SI unit of area is meter square. So Newton per meter square is the SI unit of pressure. And CGS unit, the CGS unit for pressure is, the CGS unit for force is dyne, and the CGS unit for area is centimeter square. So dyne per centimeter square. Dyne per centimeter square is CGS unit of pressure. The SI unit of pressure is Newton per meter square and the CGS unit of pressure is dyne per centimeter square. Further, this Newton per meter square is also called as Pascal. Remember all these things. This Newton per meter square is also called as Pascal, that is named after the scientist Blaise Pascal. So it is Newton per meter square is also called as Pascal. 1 Pascal pressure means 1 Newton per meter square pressure, like that. So you understood fluid pressure. That is, once again I will tell about this fluid pressure. The normal force exerted by the liquid, at rest per unit area of the surface in contact with it. The normal force exerted by the liquid at rest per unit area of surface in contact with it is called as fluid pressure. That is, fluid pressure is equal to fluid force, that is normal force, that is nothing but thrust divided by area. Fluid pressure is equal to thrust divided by area, just you can write like that also. And if F is the normal force exerted by the liquid on a surface of area A, if F is the liquid force or normal force exerted by the liquid on a surface of area A, then pressure P is equal to force F divided by A, and the SI unit is Newton per meter square and CGS unit is dyne per centimeter square. Understood? And the dimensional formula, even you can write the dimensional formula of force. What is the dimensional formula of force? M raised to 1, L raised to 1, T raised to minus 2, right, I think, okay. And dimensional formula of area is L raised to 2. So therefore you will get M raised to 1, L raised to 1 minus 2, 1 minus 2 minus 1 and T raised to minus 2. So this is the dimensional formula for pressure, fluid pressure or ordinary pressure, whatever it may be. The units and the dimension will remain same for fluid pressure or whatever the pressure. So that is M raised to 1, L raised to minus 1, T raised to minus 2. M means mass, L means length and T means time. Okay, all the things we have studied already. Okay, and this fluid pressure is a scalar quantity. So it has same magnitude in all the direction. It exerts same amount of pressure in all the direction. So it does not have a particular fixed direction. So therefore this pressure is a scalar quantity. This fluid pressure is a scalar quantity. Understood? Okay. So this is introduction. So now let us understand about some other things related to, just for your understanding, atmospheric pressure. You have heard about the word called atmospheric pressure. That is, just I will tell for your understanding. Okay. So first understand what is atmosphere. How to tell what is atmosphere. Okay, just for our understanding. Okay, the gaseous envelope surrounding the Earth's surface. The gaseous medium surrounding the Earth's surface is called as atmosphere, right? The gaseous surface surrounding the Earth, the gaseous medium surrounding the Earth is called as atmosphere, and the pressure exerted by the atmosphere, the pressure exerted by the atmosphere is called atmospheric pressure. The pressure exerted by the atmosphere is called atmospheric pressure. And the atmospheric pressure, that is the pressure exerted by the atmosphere on the surface of the Earth. The pressure exerted by the atmosphere on the surface of the Earth is called atmospheric pressure. And the atmospheric pressure on the surface of the Earth is is a constant, that is value is 1.013 into 10 to the power 5 Newton per meter square. The atmospheric pressure, that is the pressure exerted by the atmosphere on the surface of the earth, atmospheric pressure, and its value is 1.013 into 10 to the power 5 Pascal or 1.013 into 10 to the power 5 Pascal, Newton per meter square or Pascal. Okay, that is, once again I will just gaseous envelope. It is there is a gaseous medium around the earth. This is earth. Okay, let us consider this as earth. Around this earth there is a gaseous medium, and this gaseous medium is nothing but fluid. Gas and liquid both together called as fluid, and this fluid will exert a normal force on the surface of the earth because the earth is in contact with the fluid. Just now we have studied, on any surface in contact with the fluid will exert a force, normal force. The fluid will exert a normal force on any surface in contact with it. Understood? And earth, the surface of the earth is in contact with the atmosphere fluid. So atmosphere fluid will exert a normal force on the surface of the earth, and the force per unit area is called atmospheric pressure. Same concept. Okay. So and that atmospheric pressure, that is the pressure exerted by the atmosphere on the surface of the earth. The pressure exerted by the atmosphere on the surface of the earth is called atmospheric pressure, and the value of atmospheric pressure is 1.013 into 10 to the power 5 Newton per meter square or 1.013 into 10 to the power 5 Pascal. Understood? And the value of atmospheric pressure is maximum on the surface of the earth. The value of atmospheric pressure is maximum on the surface of the earth, and as you move away from the surface of the earth, the atmospheric pressure will decreases. Understand this concept just for your CT purpose or for your understanding. The atmospheric pressure is maximum on the surface of the earth. On the surface of the earth, the atmospheric pressure will be maximum, and as you move away from the earth's surface, as you go to the height, the atmospheric pressure will decreases. The atmospheric pressure will decrease. Understood? Okay. Just your understanding. Okay, you understood fluid pressure. Understood fluid pressure. What is fluid statics or fluid dynamics? Okay. So now we shall derive an expression for pressure exerted by liquid at rest. Expression for pressure exerted by liquid at rest. Okay. Expression for pressure exerted by liquid at rest, or just expression for fluid pressure. Just you can write this heading as expression for fluid pressure. We have to derive the formula. We want formula, another formula. We want for pressure. We have already a formula. Pressure is equal to force divided by area. Can you calculate that force? Just now I told a liquid is there in a container. This liquid will exert a force on the surface of the container, right? Can you measure directly this force? Can you measure directly this force? It's not so easily possible. So we need another formula through which we can very easily understand the pressure exerted by this liquid at rest on the container. Okay. So now consider a container. Consider a container. This is a container. Okay. Consider a container of cross-sectional area of cross-sectional area A. Let A be the area of the base, or let A be the area of the container. Consider a container of cross-sectional area A. Let it be filled with a liquid of density rho. Let it be filled with a liquid of density rho. So now it is filled with a liquid of density rho. A liquid of density rho. Rho is the density of the liquid. A is the area of the container. Understand all the things also. Let us consider a container of cross-sectional area A. Let us consider a container of cross-sectional area A. Let this container be filled with a liquid of density rho up to a height h. Up to a height h. So this liquid is filled up to a height h. Consider a container of cross-sectional area A. Let it be filled with a liquid of density rho. Rho is the density of the liquid. A is the area of the container, that is cross-sectional area, that is area of the base of the container. Rho is the density of the liquid that is to be filled, that is filled in the container, and h is the height of the liquid up to which height the liquid is filled. Okay. Let us consider a container of cross-sectional area A. Let it be filled with a liquid of density rho up to a height h. Up to a height h. Then, now the volume of liquid in a tank or container. The volume of liquid in a tank or container. The volume of liquid in a tank. How we will write the volume of liquid? How much the volume of liquid is there? Okay, there is a container, vessel, there is a vessel or tank is there, and that tank, cross-sectional area of the tank is A, and a liquid of density rho is filled up to a height h in this tank. How much? What is the volume of the liquid in a tank? I will write the volume of liquid in a tank, that is V is equal to, that is simply cross-sectional area into height, that is A into h. A, area into height will give the volume. I think you know the basic concepts. Basic formula you must know. Area is equal to, what is the formula? Height into base or base into length, like that you will tell. And volume is equal to base into height, base into length into height, length into base into height, like that. So volume is equal to area into height. Okay. Okay. All that things you know already. Just for okay. The volume of liquid in tank. How much the volume of liquid in the tank is? V is equal to A into H. A is the cross-sectional area of the tank, that is the liquid is completely filled in this cross-sectional area and up to a height h. Only liquid is filled up to a height h, so therefore h. If the liquid is filled up to this height h and this value will be different, that value will be h, different h. Okay. So now the mass of liquid in a tank. Now how to write mass of liquid in tank? How much mass? Mass means, you know, amount of matter. How much mass of liquid is there in that tank? The mass of liquid in a tank. So that is mass. We know that basic formula. What is that basic formula? Density. Density. Density is equal to mass divided by volume. Density is equal to mass divided by volume. So therefore mass is equal to density into volume. Density into volume. So therefore the mass of liquid in a tank, that is M, is equal to, what is that? Density into volume. Density of the liquid. Mass of the liquid we want, so density of the liquid. Density of the liquid is rho. Rho is nothing but density of liquid. In the beginning only, in the explanation only I told, the density of liquid is rho and into volume, and the volume of liquid, the volume of liquid in the tank, that is V. So therefore you can write M is equal to, therefore M is equal to rho into V, and V is nothing but AH. This is mass of the liquid in a tank. Okay. So now the weight of liquid in a tank, the weight of liquid in a tank, weight, you know weight? Weight and mass, both are same, na? Weight and mass, both are same or different? Okay, many of the SLC students will tell both are same. Okay, mass and weight both are not same, they are different. They are completely different. You will study in the first part. So it does not come here. So if I explain, it will take more time. Okay, we'll study in the first part. The weight of liquid in a tank. The weight of liquid in a tank that is given by weight. W is equal to mg. The formula for weight. Weight is equal to mass into acceleration due to gravity. All these basic formula you must know. These all are basic formula. Density is equal to mass divided by volume. You will study in the 8th standard. 8th or 7th standard you will study. And mass is equal to density into volume, and weight is equal to mass into acceleration due to gravity. Weight is equal to mass into acceleration due to gravity. This small g is acceleration due to gravity, mass. And weight of liquid we want. So mass of liquid. So m is mass of liquid. Mass of liquid is rho A H G. So therefore the weight of the liquid is W is equal to rho A H G. Okay. So now the pressure exerted by the liquid. The pressure exerted by liquid, that is fluid pressure. Pressure is equal to just now I told force divided by area, that is fluid force, and this force is nothing but weight divided by area. So therefore P is equal to force divided by area. Force is nothing but weight divided by area, and weight is rho A H G divided by area A, and now A will cancel. So P is equal to rho G H. So P is equal to rho G H. So this is the pressure exerted by the liquid at rest. Pressure exerted by the liquid at rest. P is equal to rho G H. Understood? So expression for pressure exerted by liquid at rest. So P is equal to rho G H, where rho is the density of the liquid, and G is the acceleration due to gravity, and H is the height of the liquid. Rho is the density of the liquid, G is the acceleration due to gravity, and H is the height of the liquid. So thus from that formula we understand that the pressure exerted by the liquid at rest is directly proportional to the height of the liquid. The pressure exerted by the liquid at a point. The pressure exerted by the liquid at a point is directly proportional to the height of the liquid for a given liquid. That is, for a given liquid, density of the liquid will remain constant. For a given liquid, density of the liquid will remain constant, and acceleration due to gravity is also constant. We know that small g, acceleration due to gravity, is also constant. So therefore, the pressure exerted by the liquid at a point, at any point, is directly proportional to H. That is, pressure at this point is directly proportional to height, and pressure at this point is directly proportional to height of the liquid above that point. Understood? So if you take at any point, if you take pressure at this point, the pressure at this point is directly proportional to height of the liquid above that point. Height of the liquid above that point. That means as the height of the liquid is more, the pressure will be more. The height of the liquid is more, the pressure will be more and more. Understood? If the height of the liquid is more, the pressure will be more and more. Okay. So this one, that is if we say take sea water. So in the sea, the pressure, as you go deeper and deeper into the sea water, the pressure will be increases more and more. Understood? So that is, as the height increases, the pressure will also increases. That is, P is directly proportional to H. This is called fluid pressure, or the pressure exerted by the liquid at rest. Okay. So P is equal to rho G H. Remember this formula. This is very important formula, basic formula in this particular chapter. Okay. So now let us understand. So what is gauge? What is pressure? Okay. Let us take P naught is the atmospheric pressure. P naught is the atmospheric pressure, that is pressure exerted by the atmosphere. This tank is there, this container is there, this liquid is there. We have calculated the pressure exerted by the liquid on this tank, pressure exerted by the liquid on this container, that is P is equal to rho GH. And around this container or around this tank there will be atmosphere. Atmosphere is everywhere. Everywhere atmosphere is there. So there will be atmospheric pressure. So atmospheric pressure is P naught. Atmospheric pressure is P naught. Then the pressure, the total pressure, that is the complete pressure exerted, the pressure exerted by the fluid on the tank, you can write P is equal to P naught plus rho GH. P is equal to P naught plus rho GH. That is hydrostatic pressure, that you can tell hydrostatic pressure. The hydrostatic pressure exerted or fluid pressure, you can tell hydrostatic pressure exerted by the liquid at a point is given by P is equal to P naught plus rho GH, where P naught is the atmospheric pressure, rho is the density of the liquid, G is acceleration due to gravity, and H is called height of the liquid. And now take that P naught here. So P minus P naught is equal to rho GH, and this P minus P naught is called gauge pressure, is called gauge pressure, is called gauge pressure. Gauge pressure, that is the pressure difference, the difference in the pressure, the difference in the pressure, the difference in the pressure exerted by the liquid at a point to the atmospheric pressure, the difference in the pressure exerted by the liquid at a point to the atmospheric pressure is called gauge pressure, and gauge pressure is equal to rho GH, that is to measure the pressure, to gauge the pressure. To gauge the pressure, the concept used is H. H is the main, rho is the density of the liquid, it is constant for a given liquid, and G is acceleration due to gravity, that is also constant, and H is height, only this is different at different points. So therefore, gauge pressure, that is to measure the pressure, we use H as the main concept, that is height of the liquid above that point will be the main concept to measure the pressure. Understood? So this is expression for pressure exerted by the liquid at rest. Okay. So just now we have studied the expression for pressure in a liquid at rest. Okay, and then gauge pressure. This gauge pressure is nothing but pressure difference between the hydrostatic pressure and liquid pressure, hydrostatic pressure and pressure at a point. So that is hydrostatic pressure and atmospheric pressure. The pressure difference between the hydrostatic pressure and atmospheric pressure is called as gauge pressure. Just now we have studied, that is P minus P naught is equal to rho GH. That is, this is called gauge pressure, and gauge pressure is it is mainly used to measure the pressure is height. Height is the concept on which the pressure can be measured. So that's the pressure at a point in a liquid. The pressure at a point in a liquid depends on the height of the liquid above the point. Height of the liquid above the point, and the nature of the liquid. Nature of liquid means density of the liquid, and also depends on the acceleration due to gravity. The pressure at a point in a liquid or in a fluid depends upon the height of the liquid above that point, or depth of that point from the surface of the liquid, depth of that point from the surface of the liquid, and nature of liquid. Nature of liquid means density of the liquid and acceleration due to gravity. And we observe that the pressure is independent of mass of the liquid, and cross-sectional area of the container. The pressure at a point is independent of mass of the liquid, cross-sectional area of the container. So mass and cross-sectional area of the container does not matter. Whether the mass of the liquid is more or mass of the liquid is less, the pressure does not change. Pressure changes. Pressure at a point changes if the height changes, or if nature of liquid changes, or acceleration due to gravity changes. That is, if we take three different containers, filled with liquid to the same height, some other container you take. So like this, you take three different containers. So here the liquid is filled, here also liquid is filled to the same height, here also liquid is filled to the same height. In all the three cases, if the liquid is filled to the same height, then pressure at the bottom of all these containers, will be same. Height and nature of liquid is same liquid, that is water or any other liquid. If you take oil, so water, here also water, and height is also same. In the three cases, height is also same, vertical height is also same. Then pressure exerted at the base of vessel A, vessel B, vessel C will be same. The pressure will be same. But mass, if you take the mass of the liquid will be more in the vessel B. Mass of the liquid will be more in the vessel B, then mass of the liquid in the vessel A, then mass of the liquid in the vessel C. Observe mass, you can very easily identify. This is like this. So it will have more amount of liquid compared to this one and compared to this one. This one will have less amount of liquid, but height is same. So therefore pressure is same. Understood? So this understanding you must develop. That means the pressure is independent of mass of the liquid and area of the container. And see the area of the container, area of base of the container or area. So area is different, then also the pressure will be same, provided height, nature and acceleration due to gravity are same. Understood? Okay. So now let us understand, this is first concept, pressure. In the fluid statics, we study first important point, pressure, then we shall study some more things about density. You know already, but some of the things I would like to clarify. Density. It is density of a substance is defined as the ratio of mass of the substance to the volume of substance. Density of a substance is defined as the ratio of mass of substance to the volume of substance. Okay, it's volume of substance or any matter. Okay. So now density of a substance is defined as the ratio of mass of the substance to the volume of substance. Now density of a body instead of substance, of a body. Density of a body is also defined as the ratio of mass of the body to the volume of body. Mass of the body to the volume of body. Density of a body is defined as the ratio of mass of the body to the volume of body. So now for a solid body, why I am telling this one, understand this one clearly. Solid body, that is solid sphere is there. Solid sphere means a metal sphere is there, that is a solid metal sphere. Solid sphere means inside that there is no vacant place, it is completely filled. So in cricket language I will tell, this is a leather ball. That is inside that it is no empty space, it is completely filled with matter. That is called solid body. So now density of this solid body will be same as density of the substance. So whatever the substance, this substance it may be a matter or it may be leather. Let us consider it that is iron or steel. Okay. So density of steel or iron, that will be the substance, will be same as density of this solid body. If it is not a solid body, if it is a hollow body, What type of body? Hollow. Hollow body. So now, hollow body means, so it is the football, like football. I will give the example like football. It is inside that, it will be vacant. It is not completely filled. This is cricket ball. Okay, this is football. Inside that, it is completely vacant. That is completely empty. So only matter is there here. That is substance is there only here. So for a hollow body, density of hollow body will be less than the density of substance. Density of hollow body. Just I will write, density of hollow body will be less than the density of the substance. Why? Because volume of this body will be more compared to volume of the substance. Volume of the body means entire volume of this sphere, right? Hollow sphere. Whereas volume of substance means only this substance we have to take. Only the substance, only the matter. Understood the concept? So that's why, so density of the hollow body will be less than the density of the substance, because volume of the hollow body will be more than the volume of the substance. But here for a solid body, density of solid body is same as density of substance, because volume of solid body is same as the volume of substance. How much solid body volume is there, that much volume of iron or whatever the substance is. Understood? I hope you understood this point. So this is density. Just I am trying to explain. So density of solid body will be different and density of hollow body will be different. So understand that. Okay. So now, if two liquids of different densities, if two immiscible liquids of different density are poured in a container, if two immiscible liquids of different densities are poured in a container, then the liquid having highest density, the liquid having more density will settle at the bottom, and the liquid having less density will be at the upper part. Two or more immiscible liquids are mixed in a container, then the liquid of larger density, liquid having a highest density will be at the bottom, and the liquid having less density will be at the top. Understood? It is when two liquids are mixed, when two different liquids of different densities are mixed. And one more term we will use, that is relative density. Relative density. What is relative density? I will tell. Relative density is also called as specific gravity. It is also called as specific gravity. Okay. Relative density of a substance or body. Relative density of a substance or a body is defined as the density of body is defined as the ratio of density of body to the density of water at 4 degrees Celsius. Relative density of a body or relative density of a substance, you may take it as a body or you may take it as a substance. Relative density of a body is defined as the ratio of density of body to the density of water at 4 degrees Celsius, or specific gravity of a body or specific gravity of a substance. Specific gravity of a substance or relative density of a substance is defined as the ratio of density of the substance to the density of water at 4 degrees Celsius. Density of water at 4 degrees Celsius. And the density of water at 4 degrees Celsius is 1.0 into 10 to the power 3 kg per meter cube. Remember this, the density of water at 4 degrees Celsius. Density of water at 4 degrees Celsius is constant. It is a constant and its value is 1.0 into 10 to the power 3 kg per meter cube, and it is called relative density. That is relative density is equal to density of substance divided by density of water at 4 degrees Celsius. So therefore, density of this substance or any body, therefore density of this substance or a body is equal to relative density into density of water. Like this we can also calculate the density of a substance if you know the relative density or if you know the specific gravity, and it is a unitless dimensionless quantity. It is a unitless dimensionless quantity. Density divided by density, no unit, no dimension. It is density divided by density, ratio of two similar physical quantities. It is the ratio of two similar physical quantities. Therefore, it is unitless and dimensionless, though it is just a number. It is just a number. So, relative density or specific gravity. Understood? Relative density or specific gravity. Okay. So, these are some points related to density I am explaining. That is density. So, density, just now I told, if two immiscible liquids of different densities are poured in a container, then the liquid of higher density will settle in the bottom and the liquid of lower density will be at the top. So now let us consider two liquids. One liquid is having the mass m1. If m1 is the mass of a liquid, if m1 is the mass of the liquid having the density ρ1, and m2 is the mass of a liquid having the density ρ2, are mixed together in a container. If m1 is the mass of the liquid, having the density ρ1, and m2 is the mass of the liquid having the density ρ2, are mixed in a container, then total mass m is equal to m1 plus m2. Total mass m is equal to m1 plus m2, and total volume, it is V is equal to total volume, V is equal to, so we know that density is equal to mass divided by volume. So volume is equal to mass divided by density. So volume, first volume of first substance, we can write m1 divided by ρ1 plus volume of second liquid, it is m2 divided by ρ2. So therefore density of mixture, I am telling density of mixture. Two liquids, one liquid is having mass m1 and having density ρ1, and another liquid is having mass m2 and having density ρ2, are mixed together in a container. Then the density of mixture ρ is equal to total mass divided by total volume. Total mass is m1 plus m2 and total volume is m1 divided by ρ1 plus m2 divided by ρ2. So this is how you have to calculate. This is the density of the mixture. So further, if m1 is equal to m2, that is both are same. If mass of both these liquids are same and the density is different, so under that condition, then ρ, that is density of the mixture. This is density of mixture. Is equal to m1 is equal to m2. That means m2 plus m2 divided by ρ1 plus m2 divided by ρ2. So now take m2 as common. M2 taken common and cancel it. So here m2 plus m2, 2m2, and here m2 is taken, m2 cancel, 2 divided by 1 by ρ1 plus 1 by ρ2. So on the simplification, so you will get density of the mixture is equal to 2 ρ1 ρ2 divided by ρ1 plus ρ2. So like this you will get the formula. Cross multiply these two, ρ1 plus ρ2 divided by ρ1 into ρ2. So then it will goes to numerator, 2 ρ1 ρ2 divided by ρ1 plus ρ2. This is density of the mixture. Understood? When two liquids of different masses are mixed, different masses and different densities are mixed together, then the density of the mixture is calculated by this. And further, if the mass of both the liquids is same, then the density of the mixture will be like this. Understood? That is 2 ρ1 ρ2 divided by ρ1 plus ρ2. Okay. So now similarly, so if there is a liquid of volume V1 having the density rho 1, and there is a liquid of volume V2 having the density rho 2. Their mass we don't know, only we know the volume. If there is a liquid of volume V1 and density is rho 1 is mixed with another liquid of volume V2 and density rho 2, then total mass, that is mass is equal to density into volume, mass is equal to density into volume. So rho 1 into volume V1 plus rho 2 into volume V2, and total volume we know here, so V1 plus V2. So density of the mixture, total mass divided by total volume, density of the mixture is equal to total mass divided by total volume. Total mass is rho 1 V1 plus rho 2 V2 divided by density volume, total volume V1 plus V2. By using this formula, we have to calculate the density of the mixture. Further, if volumes of both the liquid is same, V1 is equal to V2, and then substitute V2 plus V2, 2V2, and V2 is taken common, and V2 is also taken common here, so it will get cancelled. So you will get density of the mixture as, so rho 1 plus rho 2 divided by 2. Density of the mixture, you will get rho 1 plus rho 2 divided by 2. So this is how you can calculate if the volume we know and masses are don't know. This is a liquid having volume V1 and density rho 1 is mixed with another liquid of volume V2, density rho 2. Then density of the mixture is like this, or if the volumes are same, density of the mixture will be rho 1 plus rho 2 divided by 2. So this is how you can calculate the density of the mixtures. Okay. So now further, variation of density with the temperature. That is, with rise in temperature, due to the thermal expansion, the volume of a body will increase. Temperature, effect of temperature on density, just I am telling, just for our understanding in general for a solid body. Okay. So it is, if the rise in temperature, if the temperature rises, so due to the thermal expansion, the volume will increases and the mass of the body will remain constant. Mass is not affected by temperature. Mass of the body will remain constant. Okay. So due to the rise in temperature, due to the thermal expansion, the volume will increase. When the volume will increase, the density of the substance or density of the body will decreases. When the temperature increases, the density of the body will decreases. So that is, if you write a ratio of two densities, that is rho divided by rho naught. Rho naught is density at 0 degree Celsius. Rho is density at a given temperature. So mass divided by volume and mass divided by volume V naught. And m is same, so it will cancel. So we will get V naught divided by V. And V is nothing but volume. The volume at a temperature. So that is, you can write it as by using volume coefficient. That is coefficient of volume expansion. You can write V is equal to V naught into 1 plus gamma into delta theta. We have studied in the previous chapters. If you have studied, you will study in the other chapters. If you have not studied, we will study in the thermal expansion. In the next chapter called thermal properties of matter. There you will study this type of formula. So you will get rho divided by rho naught is equal to V naught divided by V. V can be substituted V naught into 1 plus gamma into delta theta. This gamma is called coefficient of volume expansion. Delta theta is change in temperature. And V is the temperature, is volume at a temperature. V is the volume at a temperature and V naught is the initial volume or volume at 0 degree Celsius. So rho divided by rho naught, V naught cancel. So you will get rho is equal to rho naught divided by 1 plus gamma into delta theta. And now using expansion, binomial expansion, you can write this formula as rho is equal to rho naught into 1 minus gamma into delta theta. You can write this is by using binomial expansion. So this formula will give the variation of density. Variation of density with the change in temperature. With the change in temperature. Delta theta will give the change in temperature. Delta theta is the change in temperature. Understood? Okay. So that is as the temperature increases, the volume of the body will also increases due to the thermal expansion. Hence, density of the body will decrease. Density of the body will decrease. This negative sign shows that density will decrease. If it comes out to be positive, then density will increases like that. Understood? This formula and this formula, if you look at both the formula, it's almost same. V is equal to V naught 1 plus gamma delta T. Plus means volume increases with respect to temperature. It all comes in the next chapter. Just it's all there in the CET. That's why I am explaining things. Volume increases with respect to this formula. This gives the variation of volume with respect to temperature. This gives the variation of density with respect to temperature. Variation of density with respect to temperature. Understood? Okay. Now, effect of pressure. If pressure is increased, the mass will remain constant. The mass will remain constant and volume will decreases. If pressure is increased, the mass of fluid or mass of liquid or gases will remain constant, whereas volume of gases decreases or volume of liquid decreases, but very, very less. Totally volume will decreases, hence density will increases. Say effect of pressure. So when the pressure increases, the volume will decreases and hence density will increases. Density will increases and the mass will remain constant. So that also you can write like this: rho divided by rho naught is equal to m divided by v and m divided by v naught, and after calculation v naught divided by v. Right. So rho is density at a pressure and rho naught is density at initial pressure. Like that you can take. And now you can write this as that is by using the bulk modulus. By using the bulk modulus, that is by the formula of bulk modulus. We know bulk modulus of elasticity. Bulk modulus of elasticity, B is equal to minus V naught delta P divided by delta V. B is equal to minus V naught delta P divided by delta V, where delta P is change in pressure, delta V is change in volume and V naught is initial volume, and B is called bulk modulus. B is called bulk modulus, which we have studied in the mechanical properties of solids. Mechanical properties of solids chapter, we have studied about the bulk modulus. B is equal to minus V naught delta P divided by delta V, where delta V is equal to V minus V naught. So therefore, you can write the formula like this: V minus V naught is equal to minus V naught delta P divided by B. So further you can write V is equal to V naught minus V naught delta P divided by B. So V is equal to V naught is taken common. V naught is taken common. So then you will write 1 minus delta P divided by B. So this is a variation of volume. Variation of volume. So now variation of density. So density will come out to be reciprocal. Density is equal to mass divided by volume. So density will come out to be reciprocal. So rho is equal to rho naught into 1 minus delta P divided by B whole raised to minus 1. Like this you can write. So further this formula, after the expansion, it will come out to be rho is equal to rho naught into 1 plus delta P divided by B. So this formula, by using this formula, you can calculate about the changes in the density or density due to the change in pressure. Delta P is change in pressure. Delta P is change in pressure. B is bulk modulus of that substance, and rho is density after increasing the pressure or decreasing the pressure. Rho naught is initial density. Understood? So like this you can calculate or you can understand about the variation of density with respect to temperature and variation of density with respect to pressure. Understood? All these things are not for theory classes, these are all things for higher level. Just for your understanding I explained all these things. Okay. Okay, this is lecture number 1. This is lecture number 1. I don't know how much you have understood or how much you did not. So if you not understood, then don't worry. These things will come in the next chapter also. These things will come in the next chapter also. In the thermal expansion will, that is mechanical thermal expansion of solids, fluids and liquids will come, and in that chapter also you will study all these things once again. Okay. So we will take in the next class. We will continue in the next class.